welcome to the session. Let's wait for a few minutes so that others can join. Hi everyone, am I audible? Please confirm by typing in the chat box. Great. If I'm audible, if I'm so let's start in a few minutes. So yeah, wait for a few more minutes so that I can set up everything. Uh, mm. 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 Mhm. So, hi everyone, is my screen visible? Can you confirm? Just type in the chat box. Great. So, welcome to this tutorial session number 5 on problem solving using programming in C. So, in this course, learn how to solve mathematical problems algorithmically. So, basically, we define some math. We convert the problems into we basically convert problems into machine program using high level language, which is C right here for you. And then ask the computer to solve that problem. So I'm Rupesh Kumar. This is session 5. And yeah, the way this session will be conducted is I have some practice problems for you guys that I'll be solving you for now. And after I am done with these problems, you can ask questions. If you have any doubts at any time, just type in the chat box. I will be communicating with you guys through audio chat, and you guys can communicate with me via the chat box. So if you have any queries at any state of time, just type in the chat box. Fine. At any instant you see that my screen is not visible or my audio is not I'm not audible, then you simply type in the chat box to ask me to rectify the issue. Fine. And if you have any doubts at any problem at any stage, just what you have to do, you have to type in the chat box. Yeah. So this is how this session will be conducted. If you have any other doubts, please type in the chat box. Otherwise, we can start the session. Do you have any doubts? Am I audible? Is my screen visible? Anyone? Please confirm. So is the font size fine with you guys? Great. Yeah, so let's start. So someone is saying screen is not visible. SK Rishi, is this true? You can't see the screen. For others, the screen is visible, no? So I will start just answering the questions. So Rishi is saying I am not sharing the content. Is this true for everyone? Can you see a page where I have written problem solving through programming in C? Anyone else? Please confirm. You can see. So Rishi, I guess there is some issue on your end. Maybe there is some network issue. Fine. Yeah. So problem number 1, the statement that transfers control to the beginning of the loop is called anyone? B, continue. That's correct. So how do we use continuous statements? So whenever you want to transfer the control to the beginning of the loop, we can use continue statements. Fine. Anyone, do you have any doubt? Fine. So yeah. So before continuing from here, I want to ask you guys, are you familiar with the concept of loops in C? So have you guys seen loops in C? So I hope you are familiar with the loops that we have, loop constructs that we have in the C programming language. Fine. So one, fine. So you are familiar with the for loop, while loop, and do while loop. These are the loop statements in C. So what are these? Loop statements in C. You can use these statements to repeat instructions. Okay, multiple times in a program. Fine. For example, for int I equals to 0, I is less than 10, less than 10, I plus plus, and simply printf a table of 2. So let's say 2 into percentage d, which is I, equals to percentage d, which is I into 2, comma I, comma I, comma 2 into I. So this is how you use for loop to write a table of 2. Similarly, you can use while loop. So let's declare some variable int I equals to 0, while I is less than 10, less than equals to 10, less than equals to 10, equals to 10. And what you have to do? You have to print something, printf 2 into percentage d equals to percentage d backslash n, comma I, comma 2 into I. And then what you have to do? I plus plus. So this is how you do the same program using while loop. And the last one is do while loop. So let's put I equals to 1 here, I equals to 0 here again. Sorry, yes. So basically table starts from 1, so I'll be using I equals to 1 again. Fine. So do what you have to do. You have to do something. What you have to do, you have to do while loop is in exit control loop. So you have to write the statement first and then while condition will come. 2 into percentage t equals to percentage t slash n comma I comma 2 into I. Fine. Now what you have to write? You have to write the exit condition that will be checked in the beginning. I is less than equals to 10 and just put in I plus plus here to increment the value of I. Fine. So these are the three ways you can use print a table of two in C using three different types of loops. Fine. Anyone do you have any doubts? What? So should we proceed, everyone? If you have any doubts, type in the chat box. Yeah. So let's go on to the next problem. So in this problem, what we have to do, we have to write the output after running this, what the computer would output after running this program. Fine. So question is hashtag include stdi. So basically we are including standard IO library. Then we are declaring the main function. I should just make it void main. Fine. Now I'm declaring a variable x equals to 1. Then do something. What you have to do, you have to continue. Fine. Fine. So you are declaring a variable x, which is of data type integer, and you're assigning the value 1 to it. Then you start the do loop. What you write, continue, then printf the value of x, then increment the value of 1, then break the loop, and then finally you have a statement that checks the value of x condition, and then print the value of x again. So anyone, can you get this? What this program would do? What will be the output? So what will be the answer? Anyone? So no, option B is not correct. Just pay attention here what is happening. As soon as you are getting inside the body of the loop, you are finding that there is a statement that says continue. Are you getting this? So can you observe this continue statement? So the what does continue statement do? Continue statement jumps control to the beginning of the loop. Fine. So what happens here? So let me show an example. Mm, um, got it. Let's go to the sketchpad. Fine. Yeah. Let's choose a pencil. So let's say how this continuous statement works. So we have this how basically do while loop works. So you have a do statement, then something inside the body of the loop, and then you check while, and then you put some condition. Fine. Then you put some condition here. So this is how this loop is defined. So what happens when you put in continue here? This continuous statement, what it does, every time a continuous is exerted, it jumps back to the beginning of the loop. It always controls the shifts the control line to the beginning of the loop. So let's say this there were few lines above the loop. Fine, there was something written here. Right, and then this do while loop comes here. So control is at this line right now. Now what happens? It goes inside the loop. So this basically goes to this line. Now what it says continue. So what it does, it again jumps the control back to the starting line of the loop beginning. And then it observes this continuous statement, and then it again back jumps back to the do statement. So what is happening? An infinite loop is going on here. So there will be no output. Option D is the correct answer. Fine, everyone. Is this clear? Great. I mean, you can fine. That's fine. So let's move on to the next question. So always pay attention while writing these using these statements like loops. You need to pay attention to such uh, cases where infinite loop can occur. Let's move on to the next question. Y will be the output of this statement. Someone is saying, can you say once more? So yeah, what I was saying is, yeah. So what I was saying, uh, let's say we have a do while loop. So it says do, then you have some block inside the do statement. So yeah, you have to do something inside the do statement. And then you have this while. And then while condition. Yeah. Fine. You have to do while there is some condition here. Then let's say we have a continuous statement here. We have a continuous statement here. And let's say the program had some statements here. Fine. So before this loop, this was the line before the do while loop. So the program control was at this line. Fine. This is the program control. Now program control comes to the do statement. So what it tells go inside the body of the do loop and do something. Okay. So you come to the first line inside the do while loop block, and you observe that it says continue. So what is the task of continue statement? The task of continue statement is someone is saying they cannot see the board. Is this true? So I hope this is visible to everyone. So the task of this continuous statement is to shift the send the control program control to the beginning of the loop. Someone is saying they you can't see the board. Is this true for everyone? Screen sharing is not visible. Are you sure? It's showing which we cannot access. You cannot access. Okay. Right. So I guess some of the students can see this. So now everyone, can you see this whiteboard? So still some students can't see this. So it's a mixed answer, like some can, some cannot. Hmm. Okay, so let me just stop this and use something else. Fine. So can you see this? Is this visible? Great. So what I was saying is, so we have, let's say, do. Fine. Now you do continue and while so condition. Fine. This should be visible. Now, let's say we had some lines before this do while loop itself in the program itself, and the program control was at this line. Now what happens? The program control comes to the first line of the do while loop. It says do. So what it says, this line says, go inside the do while loop block and execute the lines present inside this loop. Fine. So what is the line that we encounter first? This is this continue block. Everyone, can you say this line? This is this continue block. Hmm. So we have this continue block and it shifts the program control to the beginning of the program. So basically it jumps it to the do loop, do statement again. This do statement says again go to this continue statement, continue again says go to the do statement, and this process repeats in a cyclic order. So this is also known as infinite loop. So that's why the program will never exit and it will never give an output. Fine, everyone? Do you have any doubts? So someone is asking, they have a question from week 4 program. I was unable to write and same scenario with 5. So yeah, you can go back to the lectures again and this tutorial session video again and try to solve them again. Then you will should be able to do this. Fine. So yeah, everyone, I think we are done with this problem. Let's move on to the next problem. So what will be the output of this program? So we have inside the, let's directly look inside to the body of the program, which is inside the main block. So we have an integer variable x, declared a variable x that can store integer data type value. And then we are saying x equals to 4 less than 8. If 4 is less than 8, then store the output should be the a value of 5 not equals to 1, less than 5 equals to 0. If that's true, then 1, otherwise 2, else 3. Fine. So someone is saying unable to edit, write in weak programs. I don't know what do you mean by this edit and write in weak programs. So let's discuss this after I'm done with these program problems. Fine. Fine. So let's try to solve this problem. So everyone, are you familiar with the ternary operator? Condition. So what, how does it look like? You have a condition, then you check the condition, value if true, otherwise value if false. And then you have a terminator. Fine. Everyone, you are familiar with this ternary operator? Fine. So let's solve this problem. So we have this statement. Hmm. Fine. So we are familiar with this ternary operator. So let's go ahead and solve this problem. So let's first figure out what are the blocks in this ternary operator. And another thing, you can always do a mapping between to if else. So you can always transfer a ternary operator to if else statement. So for example, this same, so this, mm, so this same block, one second, just, Mhm. Okay. So this same statement can be written using if else statements like this. So we have if con condition value x equals to value if true, x equals to value if true, fine, else x equals to value if false. So this is how you can map any, this is how you can map these if else statements, this ternary operator to if else statement. Fine. So this is how you do this. So let's go ahead and solve our problem. So our problem is this. So let's try to break it down, map it to if else statements. So the first ternary block we observe is this question mark here. So let's write this. If the condition is 4 is less than 8, if 4 is less than 8, then what we have to do? We have to simply, if this is true, then you have to type do this, else you have to do x equals to 3 or x equals to this. Fine, everyone. Do you agree with this? Everyone, do you agree with this answer? With this mapping? Fine. Now let's break down and solve this. So this contains multiple operators in a same line. So let's first break this again into if else depending on this question mark symbol. So if x equals to 5, which is not equals to 1, less than 5 equals to 0. So if this is true, then x equals to 1, else x equals to 2. Fine, everyone. So now we have split down each and every statement into this statement that we were trying to solve into if else statement. So instead of solving the ternary, we simply need to solve this if else problem. Fine. So now what we have to evaluate? We have to evaluate this expression. Is 4 8 then less than 8? Is 4 less than 8? So this is the problem statement that we are trying to solve. Fine. So is 4 less than 8? Yeah, true. It is always true. Fine, everyone. So someone is asking, how did I write this? So what ternary operator looks like is there is some condition. Fine. So we are trying to assign some value to some variable. So x equals to, you check some condition. Fine. If the condition is true, then you provide this value. Else you provide this, return this value to the value x, variable x. Fine. This is how we can expand this. Krish, is this clear how I am able to map this ternary operation into if else statements? So by ternary operator, we mean an operator that involves three operands. And this is ternary if else that allows you to check some value and assign values to variables. Fine. How it is mapped to if else statements? This is how. So there is some condition written here that returns true or false. Then there is a question mark. Now, if that condition is true, the value, some values provided here. That value is returned to the variable if that condition is true. If that condition is false, then the value that is returned is provided after a semicolon. Fine. So this is how you map these. Now we have already mapped our problem into this. And now we are checking if 4 less than 8. Yeah, this is always true. This is how maths is. Now you are checking if we get inside the if blocks, the statement inside the if body of the if block. Now you are going to check this statement if x equals to 5 not equals to 1 less than 5 equals to 0. So how to solve this problem? Anyone? Can you suggest me what to do from here? Anyone, can you suggest me how to solve? How does the compiler, GCC compiler, solve executes these statements where multiple operators can come into the same expression? How to get some Boolean value out of it? Anyone? So it's a simple program. What is the output of this statement? What is the value of? Yep, someone is saying to find the operator which has the highest priority. So let me write down the precedence, operator precedence for these. So let's see. These are all either logical comparators or we have some assignment. So let's see. So for relational operators, less than equals to is get has a higher precedence than not equals to and equals to. So this less than will be executed first. Then equal to and not equals to have same operator precedence and associativity left to right. So not equals to will be executed first, then equals to will be executed, and the simple assignment has the least priority among these. So let's solve this. So first we have to solve the output of this. Then let's solve this. So this means x equals to 5 not equals to 1 is less than 5. No, this is false. So we get 0 here equals to 0. Now less than not equals to will be evaluated first. So what is the value of 5 not equals to 0? 5 is not equals to 0, so it will return 1. So we will get 1 here. Now x equals to 1 equals to 0. So now we have to evaluate this operation. So 1 equals to 0 is 0. So 1 is not equals to 0. So it returns 0. So the value of x becomes 0. Fine. So let us take a variable y here because x is already there in our program. So now this means y equals to 0. So this returns 0, which means false. Fine, everyone. Do you agree that this conditional statement will return 0? So basically y equals to 0. What does it return? It returns 0. Assigns the value 0 to the variable y and then returns 0. Everyone, do you agree with this? Do you have any doubts? So what should be the value of x? X should print 2. Option B. Fine. If you have any doubts, please type in the chat box. Meanwhile, we can also check this if this is correct. Ternary.c. Fine. So the correct answer is option B. In the first line, so someone, there are two doubts. Someone is saying in the first line, it says 1 is less than 5. So this is true. So it should be 1 as so as it is true. So no, basically you have to follow the operator precedence. Then only you will be able to solve this. So you can't start by solving this directly here. So yeah, 5 not equals to 1. 5 is not equals to 1, which is already 1. Yeah, there was a mistake on my side. 1 is less than 5. This is true. But again, it returns 1 and 5 is not equals to 1. So this does not change the output. Someone is saying operator precedence screen we write up. So this is the operator precedence. I have extracted the precedence for this desired operators that we are dealing with right now. So you can look it up on the internet also. Fine. If you have any doubts, please type in the chat box or we can proceed to the next question. Fine. So let's move on to the next question. So the following program is used to find the reverse of a number using in C language. Fine. So find the missing condition inside the while statement indicated at XXXX to solve this problem. Okay, everyone, let's go ahead and solve this problem. So we have this main statement. Now let's track the variables that we have right now. So we have declared three variables of integer data type. One is n, the other is reverse number, and the third one is remainder. And the value associated with the reverse number variable is 0. Fine, everyone. Now what I'm asking the user to print some integer as an input. So I'm writing the statement printf enter an integer. Then you scan the input to the variable n. So basically now n gets some value that is provided as input from the user. Fine. Now we have some while loop, and what it is doing, while we have to put in some condition. So the question is, what should be the condition here? What should be the condition here? Fine. So what should be the condition here so that this program returns as a reverse number? So what I'm doing, remainder equals to n modulo to 10. So modulo operator returns the returns remainder. So basically when you divide n by 10, you get remainder. What is the remainder that is being returned? Now reverse number equals to reverse number into 10 plus remainder, and n divided equals to 10. So what does this mean? N equals to n divided by 10. Fine. Now you have to print the value, printf reverse number equals to reverse number. So what should be the condition here? Fine, everyone. So let's start with the solution. Hmm. So maybe, yeah. Fine. So let's solve this. So before solving this, let's look at it, what we want to do and what is given here. So let's say user inputs a number like, let's call 1, 2, 3, 4, 5. And let's run this algorithm. Let's say n equals to 1, 2, 3, 4, 5 and reversed number equals to 0 and then remainder is blank right now. Fine. And we are here. So let's say our program control is here. Fine. Now, what is the condition? Let's assume that the condition is true. So let's say this condition is true. Just assume that the condition is true. Then I'll assume it to be true. Okay. So let us assume it to be true. Now what we are doing, we are saying remainder equals to n modulo 10. So what should be the value of remainder here? So then remainder should be 1, 2, 3, 4 modulo 10. So what is the value of 1, 2, 3, 4 modulo 10? Anyone? It should be 4. So when you divide this number by 10, you get a remainder 4. So how would you do this? So 1, 2, 3, 4 can be written as divided by 10 can be written as 1, 2, 3, 0 plus 4. So 1, 2, 3, 0 is divisible 123. So 123 into 10 plus 4. So 4 is the remainder. So the value here is 4. Now remainder contains the value 4. Now what is the value in the stored in the reverse number? Reverse number becomes 0 into 10 plus remainder. So what is remainder? 4. So our value reverse number becomes 4. So now reverse number contains the value 4. Okay. Now let's move on to the next line. Now n becomes n divided by 10. So n becomes n divided by 10. Fine. So n becomes n divided by 10. Now what you can do, what you have to do, you have to update the value of n equals to integer division n divided by 10, which becomes 1, 2, 3. Fine. So now one reverse number has the value 4 and n has the value 3. So yeah, let's proceed. Now let's assume the condition is now again true. Fine. So now what happens? So now let's assume that the condition is again not true. Again, the condition is again true. Then again execute this line. Remainder equals to n modulo 10. So now remainder becomes 1, 2, 3 modulo 10, which is equals to 3. So now remainder is 3. And then update the value of reverse number. So reverse number becomes uh, it was already 4, so it becomes 4 into 10 plus 3, which is 43. Fine. And n becomes n divided by 10, which is 123 divided by 10, which is 12. Fine. Now let's repeat the process again. Let us assume that the condition is still true. Let's assume that the condition is still true. And let's again update the value of remainder. Remainder equals to n modulo 10, which is 10 modulo 10, which is 2 here. Now our value becomes 43 into 10 plus 2, which is 432. And n becomes 112 by 10, which is 1. Fine, everyone? Do you agree with this? Are you getting? I'm just assuming that x is true. I'm assuming that this is true. So let's call while true. And then I'm just repeating the loop and let's see where it goes. Fine. Now again, let's put a remainder equals to n modulo 10, which is n was 1. So it would be 1 modulo 10, which is 1 here. Reverse number becomes 432 into 10 plus remainder, which is 433 to 1. And then n becomes 1 divided by 10. In integer division, it becomes 0. Now, what is the value stored in the reverse number? Everyone, can you say this? The value is 4321. Everyone, can you see the value? Am I audible? Great. So is this clear? So what you are seeing? You are seeing that when as n reaches 0, as n reaches 0, as the value of n becomes 0, you can see that the reverse number variable contains the value of the number in the reversed order. So n was 1, 2, 3, 4. So now reverse number contains 4, 3, 2, 1. So what should be the condition here? The condition would be n not equals to 0. Fine, everyone? Option A. Fine, everyone. If you do have any doubts. So when n goes to 0, you will get the reverse number. Fine. Anyone do you have any doubts? Please type in the chat box. The answer is n not equals to 10. Not equals to 0, sorry. Option A. Sure, do you have any doubt? Yeah. So what I'm saying is how to solve this problem. You want to fill in the blank. So what you say, you assume that this condition is true and repeat these steps. So there will be a stage where you will observe that when n becomes 0, you will see that you will get the reverse number. So this is the condition where you have to stop. So now that will be the condition here. Now, how to understand this program, how it works? Let's look at that. Um, just a second. I'm not able to share. Fine. So let's look at this again. Nvim reverse dot c. Fine. The text should be visible to you guys. Then void main. Now let's say we have a number 1, 2, 3, 4, and let's declare a variable reverse, and then we have a remainder. Fine. Now we have some condition. Now you want to compute the reverse of that number, and finally tell the user the reverse of whatever number is something else. Change the line and comma reverse. So let us take a copy. So let's take the copy of this variable n here so that we can print it here. So let's call temp n and let's assign the value int temp n is to n. Fine. Now what should we do? How should we proceed? So you can say that see that n can be written as 1, 2, 3 into 10 plus 4. Everyone, is my screen visible? So is my screen visible? Someone is saying my screen is not visible. Great. So yeah, how to solve this problem? How to think of this? So you can always write 1, 2, 3 in 1, 2, 3, 4 as this, or if you expand it again and equals to 1 into 1,000, 1 into sorry 1 into 1000 plus 2 into 100 plus 3 into 10 plus 4 into 1. So this is how you can write 1, 2, 3, 4. Someone is saying not still not visible. Is this the case of majority of you? If that's the case, then there is some network issue on my side. Otherwise, you guys have some network issues. So I'm getting mixed results of what is it visible. So I should just reshare my screen. Um, Now, is everything visible? Please confirm. Great. So now, do you agree with this? We can write n as like this. The value of n is like this. So every place's digit multiplied by its place value. So n equals to 1 into 1000. So and 1 is at the thousands place, 2 is at hundreds, 3 at tenth, and 4 at one. Now, what is the reverse of n? Reverse of n is 3, 4, 4, 3, 2, 1. Fine. How to write this? Reverse equals to 4 into 1000 plus 3 into 100 plus 2 into 10 plus 1 into 1. Fine. Now we want to replicate this with the while loop. Fine. If we want to do this while loop using while loop. So what we are observing is first we want to get the first digit from the left hand from for least first least you start from the least significant bit position digit position, and in this 1 2 3 4 4 is the least significant digit. Take that value and multiply by 10. So let me do this. Let me take the last value, least significant digit, which is 4, multiply by 10 and store it in the variables reverse. Reverse equals to this. So what it becomes? This becomes 40. Now what you do? You take the reverse equals to reverse into 10, multiply by 10, and then again the next least significant digit, which is 3. So don't multiply by 10 here right now. So just assign the value of the least significant digit to the variable reverse. And then what you do in the next line, what you do, you multiply by 10, the value stored in the reverse, and then add the next least significant digit after 4, which is 3. So it becomes 40 plus 3, which is 43. Fine. Now again, what you do, reverse, repeat this, reverse multiplied by 10 plus the next least significant digit, which is 2. So it becomes 430 plus 2, so which is 432. Now, as the last step, what you do, reverse equals to reverse into 10 plus last significant digit, which is 1. So it becomes 4320 plus 1, which is 4321. So this is how. Now, what is the value of n now? It becomes 0. Fine. So this is how you do this. And how to do this using while loop. So we can already see that there is some structure. You can repeat some statements are repeating again and again, such as reverse equals to reverse multiplied by 10 plus, let's call it remainder. So we already have declared the variable remainder. Let's assign the value of 0 to reverse. Fine. Now how to get the least significant digit from the variable n. So the least significant digit is exactly the remainder of dividing n by 10. So when you divide n by 10, the remainder is the least significant digit. Fine. Now the last thing is how to update the value of 10? So you can set n equals to n divided by 10. Here we are doing integer division. Why integer division? Because we want to remove the least significant digit from the variable n. Fine. Now what should be this condition then? So what should be the condition here? The condition is when n goes to 0, then you have to exit. Why? When n goes to 0, you will be adding 0 every time to reverse. Fine. So that won't help. So reverse equals to reverse into 10 into 0, 0, 0. So it will be adding zeros infinite time number of times. So you need to stop there. That's why you need n equals to 10. Fine, everyone. If you have any doubts, please type in the chat box. Is this clear? Hi everyone, am I audible right now? Hello, am I audible right now? Great. So yeah, let's take a break for few more minutes and then we should resume. Hi everyone. So am I audible? Is my screen visible? Great. So let's resume. Hmm. So the program says, problem says, compute the printed value of ing of the C program given below. So let's directly jump inside the main block. What is written inside the main block? And let's try to solve this. Great. While I is less than 8, j is greater than 9. So we have two variables, integer. One is I, another is j. I'm assigning the value of 0 to I and 15 to variable j. And then while I is less than 8, comma, j is greater than 9, I plus plus, j minus minus, printf, I and j, and then return 0. So everyone, are you familiar with this? Do you remember this? Do you remember this comma operator? I hope you remember this comma operator, what it does. So let's see the comma operator. What it does. Evaluates the value of the expression and then of the expression on left, then evaluates the value of the expression on the right, and then returns the value evaluated on the right. Fine, everyone. This is what comma operator does. So let's see what is the output of this stuff here, this condition here. I is less than 8, comma, j is greater than 9. So what is the value of I? I is 0. So I is less than 8. That is true. So now again, it ignores this output and then j equals to 15. So is j greater than 9? Yeah, true. So it returns 1. So this condition becomes true. So the value of I is updated. So now I becomes I plus plus, which is 1. J becomes j minus minus, which becomes 14. Now again, control goes back to the while statement here. So now control jumps back to here. Okay. Now you again check while so simply you have to check if j is greater than 9 because this statement does not changes the outcome of this conditional expression because there is comma operator here. So just every time keep checking the value of j greater than 9. So j is 14. That's true. So I gets incremented. I becomes 2. J becomes 13. Then again it repeats. So j minus minus happens again and again. J plus plus happens one again and again. So j becomes 3. I becomes 3. J becomes 12. I becomes 4. J becomes 11. I becomes 5. J becomes 10. I becomes 4. 5 comma 6. J becomes 9. Now it says j is not greater than 9. So program exits. The while loop exits and we print the value of I and j. I is 6, j is 9. So option C is correct. Option C. Fine, everyone. Do you have any doubts? Anyone, if you have doubt, just ask me. Just type in the chat box. So yeah, what is a comma operator? So what comma operator does is it's a binary operator essentially. So let's say we have left expression here, then right expression here. So is this visible? So this is our left expression and this is our right expression. Then what comma operator does is first evaluates left expression, then evaluates right expression, and finally returns the value returned from the right expression. That's all this operator does, this comma operator. Fine, Steven, is this clear? So let's say it says, let's say it says, mm, what we can say x, so x equals to 1, comma, y equals to 2 plus 3. And now let's say we have some operator z equals to this, something like this, some variable z. So what will the value of z? First, he will evaluate the value on left, so x becomes 1. Then it will evaluate the value on the right, so y becomes 5. And we all know that this equal to operator y equals to this assignment operator returns the value that is being assigned to the variable y. So z gets the value of 5. So this is how this works. Fine, Steven. Now do you get how comma operator works? So Krish is saying explain again. So again, we know that it ignores the evaluation on the left hand side, and left hand side is the value on the left hand side of this comma operator is not doing anything. It's just checking the if I is less than 8. Fine. So let's ignore this until ignore this every time because this will not change the value of this conditional. Let's check the value on the right hand side. So every time check j greater than 9 and then just evaluate this, repeat these statements and you will get to the answer. Fine. If you have any doubts, type in the chat box, please. Great. So let's move on to new questions. So someone is saying if 10 is greater than 9, then how is j 9? So why? Now when j becomes 10 here after this operation, then again this is true. So again you decrement the value of j by 10, which is equals to 9. So this is how you get 9. And the next time you check 9 is greater than 9, it returns false. Fine, is this clear, Shod? Great. So now these are some problems that I wanted to solve for you guys. Now we have some practice problems that I will writing programs for them. Fine. So let's start for these programs. Fine. Is my screen visible? So let's solve. So let's solve. So this was some problem for if and else statements that you should solve on your own. Fine. I will not going to solve. I'm not going to solve this for you. So assume that this is a homework. Let's proceed with the other problems. Fine. So write a C program to print all alphabets from A to Z. Fine. So let's solve this problem first. Okay. So let's start. Question number 7. So is my screen visible? Can you see the program I'm writing right now? Hello, am I audible? Am I audible? Yeah, great. So let's do this. Let's write a program to print all the alphabets in English language. Fine. So our program should output something like this: A, comma, B, comma, A, comma, B, comma, C, comma, D, comma, E, comma, up to Z. Fine. Let's do this. So before doing this, I want you guys to take a moment and look at this ASCII, the idea of ASCII values, the way of representing numbers in programming languages. So I will explain this program in a bit. So before that, I want you guys to have a look at this stuff. So let's look at this program first. So now you can see I printed 65 here. So I am writing printf percentage %c, comma 65 here. And you can see the program is outputting A. Can you see this, everyone? This A here. So let's print some. So you can see the program is outputting A. Everyone, is this visible? So I was printing 65. I was printing 65 from my program and I was the output is A. Why is this happening? So this is happening because of this percentage %c format specifier. What is percentage %c? It is for character format specifier. Fine. So specifier. Fine. So percentage %c is a character format specifier. So let's again see what happens here. So the C programming language follows the ASCII values. So what is ASCII? ASCII numbers are numbers that represent characters on a keyboard. So this is basically American Standard Code for information interchange. So for each character in the English alphabet, we have some numerical value associated with it that you can look at this chart. So for the capital A character, we have the value 65. Everyone, can you say this? So you can see all the English alphabets in capital have values from 65 to 90. And all the alphabets from in English alphabets in small letters from A to Z is from 97 to 122. Fine, everyone? Is this clear? So now in C language, whenever I try to store an integer value belonging to these to a character variable or trying to print it using the percentage C access format specifier, they will be converted to the string of whatever character they belongs to. So let's go ahead and go back to our program. So what we are doing, we are printing the values 65 and 65 is essentially belongs to integer character A. Fine. So now what we have to do, we have to loop it for all the alphabets in C. So I become start with I. We store the value 65 to a variable I, while I is less than equals to 90 because we know the English alphabets go up to 90 for capitals. Then increment the value of I. Then print the value of I here. Right? This will do the this is a desired program that we want. So what we are doing, we are taking the ASCII value of A65, starting from there, printing it using format specifier for a character. So it prints the character A here, then repeat it until I reaches 90. Fine, everyone. So this is how you do this. And then you gcc 7.c and run the program. So you can see we have successfully printed A to Z here in capitals using singles loop. Everyone, is this clear? Do you have any doubts? Please type in the chat box. Okay, so you want to see the program. So this is the program. So these print tabs are just for better readability. So I wanted to show the output in the middle of the screen. And then I'm iterating from I equals to 65 to 90 and printing the value in the format specifier of a character. That's it. Fine, Steven, is this clear? So if no one has any doubt, should we proceed? Shall we proceed? So I guess no one has any doubts. Let's move on to the next problem, programming problem. So now I want to print all the even numbers between 1 to 100. Yeah. So yeah, I guess each of you one can now solve these problems on your own. These are really easy problems. So number of digits we already saw. Power is also easy. If you want me to solve, just tell me in the chat box. This is a problem that I want to solve. So write a C program to check whether a number is Armstrong number or not. So I want to solve this problem for you guys. Fine. So for this, we need to understand the definition of Armstrong number. So Armstrong number is number that is equals to the sum of each of its digits, each raised to the power. The power is number of digits. Yeah. Hello, am I audible? There was a network issue. Fine. So I hope now you get the idea of what is an Armstrong number. For example, 153 is an Armstrong number. So let's say GCC Armstrong dot C. Oh, sorry, anyway, Armstrong C. Fine. Fine. So for example, 153 is an Armstrong number. Why? Let's check. So Armstrong number is number whose value is equals to the sum of its digits raised to the power of 3, raised to the power of number of digits. So 5 raised to power 3 plus for 3. So which is 1 plus 125 plus 9. Plus 27, sorry. Yeah. So when you add these three things, you will see that the value is 153. So such kind of numbers are known as Armstrong numbers. Fine. Now let us declare a variable. Let's say we have some number 153. I want to check if it is Armstrong or not. How to do this? First, I will have to count the number of digits in this number. So now let's create a variable temp that contains the value stored in the variable. And why I'm creating temp? Because when we count the number of digits, and when in the end we want to check the uh, in the end we want to check if it is Armstrong or not, then we will need the actual value of number n. But since the way we extract the digits in the number, we divide it by 10 every time and make it 0 in the end. So we will lose the value stored in the variable n in that way. So for that, what we can do, we can simply create an auxiliary variable temp that contains the value, stores the value of n, so that we can use it later on. Fine. So now let's count the number of digits. So int n digits equals to 0. So you simply say that temp divide equals to 10. So every time you divide 10 by 10, when it gets 0, this means all the digits have been removed, and so we can simply end digits plus plus here. So now we know that how many digits are present in our number. Fine. Now what I have to do, I have need to need the value of temp n again. So I again assign the value of n to the variable temp. Now this time what I have to do, I have to extract these variables one by one and raise them to a power of n digits, and then I have to add them up. Fine. So let's call this variable sum to 0. So let's extract the digit int digit equals to temp. What is the trick? Remainder on divisible by 10. Now what you have to do, you have to add the value sum equals to sum plus digit raised to the power. So we can use the function pow. Pow is an inbuilt function in C that allows you to raise a number to given power. And now temp equals to temp divided by 10. So simply start removing the digits. Now in the end, if sum equals to number, we can print percentage D is an Armstrong number, is the line which is n here, else you have to print percentage D is not Armstrong number, and comma n. Fine. So this is how you write this program. Everyone, do you understand this? So it contains a bit of steps. First step is computing the number of digits. Then the second step is extracting each digit and raising it to the power of number of digits, and then adding it to the variable sum. So the basics are same as reversing a number. So this is how you extract a number from a digit, from a number. Extract digits from a number. Fine. Anyone, do you have any doubts? Okay. Okay. So another thing that we need to pay attention here is for using the pow function, you need to include the standard header library math.h. So this pow function, where is this? This pow function is present in the math.h header library. So if you want to use it, you need to include the math.h header also. Fine. Now just run the program. Okay. So if there is no pow, let's me look. There is C power function. Pow function. Huh. Acha. Okay. So it does not accept integer, I guess then. It does not accept integer. Oh, let's convert each of them into floats. So it seems that it does not accept integer. So I can simply convert this integer to float, and then it would work. Float digit equals to float of this. If sum equals to so this is what I'm doing. I'm simply typecasting. Fine. Okay, I'm doing it wrong. Achha. So again, it's saying undefined. Okay. Okay, let me see. I think I need to link something. Acha, I need to link math libraries, no? Just a second. So yeah, there is another thing that needs to be paid attention to. So whenever you are including some external libraries, you have to link them also. Fine. And how to do that? So you have to use, so since I'm using math, you have to link using lm. Now the program runs and you can see 153 is an Armstrong number. Fine, everyone. Fine, everyone. Is the program clear? So why the program was not compiling? I was not linking the math header, my math library here. So now I'm linking using -lm here. Now I'm able to do this, and now you can see our program works. Fine. Anyone? Do you have any doubts? Please type in the chat box. Anyone, if you have any doubts, please type in the chat box. Otherwise, you can also refer to this video again, or you can ask me in the next session. Fine. So other than that, you can solve all these problems on your own. Shanu, what was the issue? So can you repeat your query so that I can resolve it? No, you have to type your queries. I can't allow you guys to speak. Otherwise, it will be a chaos. So what you are not able to write?